Hi. This session will understand how to perform a gate level simulation. So before starting with the gate level simulation, I'll just do RTL simulation, and I already synthesized and the netlist file is generated, and using that netlist file we are going to do the gate level simulation. So before that, I'll just show you the directory which I created. So I have two directories. One is RTL simulation, the other one is gate simulation. Again, in RTL simulation. So now I'll move to RTL simulation, and then I have design file and a test bench file. So to do simulation, we know the command VCS -v -r and debug. So it's done. Now we'll see. So executable got generated. Now we can use /simd, and you can see that. So next step, we will perform a gate level simulation. So to start the gate level simulation, I'm just moving to the gate level simulation. So where I have three files. The first file is the test bench file, which we use the same one for RTL simulation. The second one is a netlist file, and the third one is a .v file, which has been provided by the vendor, which will have the information about the cell that has been generated in the netlist. Okay, so the cell information has to be given, right? Because the netlist.v file will have various cell instance names only. VCS compiler won't understand. So the detailed information about the various cells which is available in SAED 90nm.v. So the target technology library is important in this case. Before proceeding with the gate level simulation, there are a few minor steps that we need to carry out. The first step is modification on your test bench. So before modifying the test bench, we'll just open the netlist file, and then we will see right. So if you see, I think there is two modules in this case, and if you see, this is a lower level module, right? So this is a lower level module. The same module name has been used. So basically what we'll try to do, we'll open the netlist.v. Okay, this is a module name, copy paste it. So we'll just make a mistake, just go through the complete netlist. Now we identify that this is going to be a top level module, and this is the module name. Next step, we just open the test bench, and we need to rename the module name with the module name of the counter. So in this case, it's going to be counter_1, because in the earlier case it will be like counter might be, which you might use in the RTL code. So that's something you can keep as it. There is no need of changing anything in your test bench. Next, I'll do the simulation Now before loading netlist, we need to load SAED. Then only it will understand this is information which is there in the SAED 90 nanometer. Then the next step is going to be counter. So it has taken all the cells from the .v file and it has done. So now it has generated that is a simulation executable simv. Again the same command /simv. Instead of doing it in I'm opening graphical user interface so that we can able to understand. So here a counter module, clock reset, add to wave, and then simulator start counting. So then you can play with that. So for zoom in we'll use plus. So now we'll see is there any difference. So this is my clock rising edge and you can able to see there is a delay in your output. So you can able to observe that, right? So this is your clock rising edge of the clock and your output is not happening exactly at the rising edge of the clock. So there is a delay over here, right? So what we will do is we will see the same thing which is happening on RTL simulation. We will simulate and then we will open in GUI mode and then we will see whether we can able to observe that. I'm just opening that from RTL simulation. Simulator. Continue. So now you can able to see the difference. So it's exactly happening, right? So I'm getting an output exactly at the rising edge of the clock. So the timing information is not at all there in your functional simulation, which you can able to observe that in a gate level simulation. I hope this gives a clear idea. So to summarize, we need to have for gate level simulation we need to have a netlist, we need to have a test bench, and then we need to have a .v file provided by the target technology vendor, which will be the same target which we have done synthesis. Then we can do a modification on the test bench using the module name which is generated in the netlist file, and then we can do the simulation, and then we can view in a graphical user interface, and then you can able to see the difference. That's all for the gate all simulation. See you then.